And it's quite an interesting topic when you want to talk about data persistence in containers. Um, Containers always store some data, and this can be data that is managed by Docker, or rather data that is managed by both, not by both, but by users. So two problems are leading to us having today's session. So one of the problem is be sharing my screen in a few. One of the problem is for instance, I want us today to use a database image. And to be specific, I'll be using MS SQL database. So I have an image for MS SQL.
So, Jonathan, will you share the screen maybe?
Oh, sorry.
Yep.
Okay. Cool. Sorry for that.
No
Let me
worries.
see. Yeah, should be up now. Um, so today I have this database and we'll be using this database. So for instance, you are not interested in installing the database or following all those processes to just install the database, but you still want to use the database. So in that case, in a case where installation is not a must, then to me it sounds like a case where we can use Docker, where we can just spin up a container about this database, and then we'll be good to start using the database. So right here, I will pick one of these images. They are just different versions, 2019, 2022. So I'll just go with the 2022 version. Seems like the latest version. And then from there, I can decide to paste this image in just any terminal. For this case, I'm just using Visual Studio Terminal. And for these, okay, this is not going to take a lot of time, but let me see if I have an image that is already existing. Yeah, I have one for MS SQL 2019. Yeah, so instead of us using the 2022 version, which is okay, it's the version that I wanted to use anyway. Just have it load on the background, but we can spin up a container with the 2019 because it will be a bit faster because I already have it installed. So as you can see, it's just starting immediately. But inside my containers, I already have now this image running, but I'll have to recreate it again so that we can understand what is happening. So we say Docker run, and then this means some environment variables, or rather some things that we can call secrets in our environment. And then this accept part is more of like the part where we always accept terms and conditions, just saying yes. And this MS SQL SA password means the password that we'll be using to log in. Every database has this root admin and a password that you can always use to log in. So that is where we are going to do our first modification. You're supposed to give a strong password. So after the is equal sign, you can now give your own. Just make sure it's strong, special character, uppercase, lowercase, a number. So I'll just use root at 2024. The other part is about the port. We are using 1433. That is the default port of MS SQL Server. And the last part is the image that we are spinning, which is now the MS SQL image. But before we even go there, I like us to assign this image a name, just call it DB, and then the image will be up and running. So in other case, we can say we are running now, or we have running the database with Docker, and we can even connect to it. So this is always my terminal whenever running this locally, but just to show you that I'm not running it locally, or the installation part that you have to do, just to show you that, let me open the configuration so that I can show you that I've stopped it from running locally. So this is always the instance of MS SQL that runs locally. So I've stopped everything that helps MS SQL run locally, and because I want to run it on Docker. So if I try my local password or those things, they won't work at this point because I've stopped that. Now I need to connect to the image that we have created in Docker. So I'll click right there. If it was locally, probably I'll select my desktop. But since it's not locally, apologies for this small font here. I'll write local host. I'll give a slash with DB. DB is the name of your container. So you just give the name of your container. And after that, a comma, and then the port that is running on. So we can always get the port from right this here. It's 1433. So that will be my, we can say, server name. The password, the login is SA, which means super admin. As you can see here, we created a password for super admin. And then the password, we use root at 2024, and then I'll connect. So as you can see, this tiny icon there that is showing you that you're connecting to something in something that is that Linux icon. It's very tiny. Don't know how to increase the font of this stuff. Very tiny, but there's a small Linux icon right there to just tell you that you are connected to the container. And now inside this container, we can say create database to do. Let's say, for instance, I want to create a to-do database, and I can execute that. And inside here, I can see a to-do database is created. And even when we now go to the logs of our container, we'll see there's some preliminary do is started for database to do, which means they are kind of communicating to each other, and also saying that they are also communicating to each other. But now I want to do something. I want to delete, or you could have run using a Docker command. I want to say Docker stop DB, which will now stop this container from running because it was running state, now is in a stopped state. And then we can even do Docker rmdb, that is the command that is to remove the database completely, and now we can see it there. So the database is removed, and now I want to rerun it again. So I've removed it and I've rerun it again. and you can see the logs are starting afresh as we go on. And now I want to say something like use to do. So it's just an SQL command that says now I want to use the database that I've created and execute. Now, upon executing, I see that database to do does not exist. And if I do a refresh here, let me try to, as you can see before I do the refresh, these are to do, but if I do, to do has gone. So what just happened? What just happened is we add this to do when the image was running, and it was okay until I stopped the image. So whenever I stopped this image, what happened is whatever we had done is redone, or the queries that we had written, the database that we had written, the tables that we might write here, they'll all be lost. And that is the whole idea of volumes. So sometimes you want whatever you wrote not to be lost, because it means that every time you run a container, you have to run the queries. Whenever you just by mistake stop it and rerun it again, you'll have to rerun the queries again and rerun the queries and rerun the queries, which I'll say is not a good cycle or something. We need to have something that can help us automate that process, or rather perform that process better, and that is volume. So now there are three types of volumes that we have. We have a volume that is called anonymous volume. There is a volume that is called named volume, and these two volumes are managed by Docker. Don't know if we can do a readme here. Readme.md. So there are three types of volume. One, we have anonymous volumes. We have named volumes, and we have something called bind mounts. So the first volume that I want us to look at is named volume. And we say that anonymous and named, they are managed by Docker. The other volumes are managed by the user, you and me. So wherever these files will be stored is somewhere that only Docker knows. But the thing is, it's still in your laptop, but only Docker knows and understands. So it will set up a folder, a path on your host machine, and the location is exactly known to Docker, not us. But with us, we don't need to know the location. We just want our data to persist. So for the first volume, let me give you the right use case. This named volume is going to help us with the current situation. The current situation says that we lose our tables, our database every time we stop the container. And just to show you that, let's create this database again, execute. If you come here, you refresh, it's there. If I delete this container, I'll just use the graphical user interface this time. You can use stop and all that. I can see my 2022 image is loaded now. If I come here back and just rerun this, which will restart or recreate the instance again, come back here, the instance is there. But if we come back here and refresh, whatever we had done is lost. So we need something that can keep these queries, databases, tables that we are creating. So that is a named volume, and it's so easy to use. First, it's not something that is going to be in your Docker file. So previously we had Docker file. Apologies, it's me in my other laptop. I'll be switching into it later. But this is not going to be inside a Docker file. So first, let me clear this and just type that command right there. And actually, I'll just remove this image right there. And for volumes, you will use -v. And for named volume, something that we can say data, just the name. You give a name at the beginning, and then a colon. And then after this colon, you give something that stores the logs of, for this case is for MS SQL. So the logs are always stored in something called var.opt MSQL. So these where the logs are always stored, logs configuration. So they can help us with keeping track of that, and Docker can know that these things were created while this database was on. Docker can save this in a folder that we don't want to know about. And whenever we stop this container and rerun a new one, Docker will attach that folder that was saved to the new instance that is running. So with this, let's run that. And now you'll see part of your volumes. There's a volume that we are managing called data, and we are binding it to the MS SQL file, to an MS SQL file, and you can always find the files here. So this is more of like the same thing that you can find in a program files, those program files. So we are storing it in this for, we are checking the logs from this part, MS SQL. So you can see here there are some logs, which include some of the data, some logs. So these are going to help us or help Docker know which database and tables were created during or whenever this container was running. So again, at this point, we just start with our database had disappeared, but hopefully now when we create one, which has just been created, and we can just refresh this, you can see the database is there. And I decide maybe mistakenly delete this container, and I'm like, I don't need that container for now, but at some point I need that container, and I want it loaded with whatever I did before deleting it. So with that, let's see if this will actually be of help. But for instance, you can see some things are happening, like to do somewhere that this, some of the logs are showing us that they might be actually remaining. So now if we refresh after deleting a container and restarting it again, we still get our database and queries. So this data was persisted. So what happened is whenever we persisted, a folder was created somewhere, and you can see some of the volumes are registered here. So a folder is created somewhere, which is not something that we are really concerned of, but it contains the logs and everything to know, to deal with Docker knowing how to recreate everything that was created whenever this container was running. So that whenever we stop this container, delete it maybe, and create a new one, we can attach that volume or that folder to the new container, and it can know about the history or whatever was being done before this before this new image was created. So you don't lose your data, you don't lose your tables, you don't lose anything. And this data will survive even container deletion, container stopping a container. This data survives for instance, if I just come here and delete this container permanently and just go to volumes, the volume is still there. Even if you deleted the container, the volume still remains. So that means that whenever we just spin a new container, this volume is going to be attached with the new container because it's a container for MS SQL. This volume was created for MS SQL. So we just need to attach the new volume, the new container to an existing volume, and it can know that there was some database code to do that was created. In case it had data, that data will still remain, and all these will be now backed up and we'll have everything that we need for this case. And that's how you can persist, or you can prevent losing data whenever dealing with an image. This is a very good use case whenever you are dealing with databases, because with databases, if you don't use volumes, then it means every time you're going to be losing your data whenever your image stops. And that means you just keep your image on, which yeah, can happen, but uh, why should you be afraid of losing data when you can back it up with a volume, and a volume will be attached to the new containers, and you don't need, it's just an extra command and everything is done. So that is the first volume that I wanted us to look at. The second volume, for this one, I love to now change my laptop. Uh, Sorry for these. These will take a few seconds though. But let me try switching. Okay, nice. Awesome. Okay, yeah, there we go. So nice. Sorry for that. One laptop was working well with the database. The other one was giving me trouble. And for the next example, this one will still survive. So with this case now, we have covered one case where we won't lose our data. So I want us to go back to our image, and it was just a simple node image. And one of the things that I want us to do is try to see where we can use volumes also in this case. So previously we had said there is an empty volume, which is managed by Docker. But now I want us to talk about a volume that is managed by the user, or me and you. So we kind of know these folders where they are, or everything that is happening. And for that, I want us to start by just a minute, be sharing this. I move this to the other side. I want us to create first an image for this application, and this is my stuff. let me write clear there for previous commands that I'd written. And for this one, I'll just increase the size. I want to create an image based on this Docker file, just a preview of what this is doing. We need Node to run this project because it's a JavaScript project. And we create a working directory, so it's more of like a folder. We copy these two files, that is package.json and package.json, into that directory. We run npm install, so that will now produce a node modules folder on that side. And then we do we copy the rest of the code into that folder. So the rest of the code, which means now index.js and any other file that will be there. We expose a port 4000, which because containers are isolated, so you need a port that you need to bind to an external port so that it can work on your side. And then we give a starter file, which is npm index.js. And now if we just do npm index.js here, you should probably get this. I think I need to reinstall node modules. So let me just do that. This is more like this command, this npm I. It's more of like npm install, so you can short form it to npm I. And now, oh yeah, and I said npm should be node, sorry, my mistake. Index.js, and we see server running, which means that our project is working well. Now, the problem is, we have seen the other one was losing data, persistence, all those. Now, this one is whenever I change a part here and okay, let me first keep it as it was. We build the image. So first I'll say docker build. I'll tag this image as just node tests, and I'll put a period at the end to just simplify, to just say that you'll find the Docker file to build this image right here. And that image is built right here from my list of images. I can see it right there alongside other images that I'm not using right now. And we can say docker run to just create a container. I'll give this container a name of node container. I'll bind it to a port of 4001 from the port that was exposed, which was 4000. There's two remove flags that I can do. This means that whenever this container stops, I can remove it, or whenever it's not in use. It's just a command that is added there for some cleanup. But you don't, if you don't want to keep containers running, and especially if you now have volumes, you don't have to keep the containers that you're not using. And the other thing that we need to say is, I don't think there's any other thing, so we can just say node test. And you see a non-command index.js, so might be happening right there. And now, actually, we start exposing our problem. One of the problem is I have to rebuild this image again because of a tiny change. And okay, the cache helps sometimes. It's going to help us with some of the things, but if I do this unknown command index.js, let's see that command from Docker file. Maybe also there's an issue there. Yeah, it's not. What did I write npm? Anyway, so now it should be node. Sorry. So again, I hope you are noticing some of the issues because we are building on top of the problem. Is that every time I need to change something, I have to rebuild this image. And hopefully now should work. Server is running. Perfect. So our container is running. And okay, at this point it has locked the terminal, and the only way we can only access another terminal by just exiting this one and opening another. So what I'll do is that mode is called attached. That now locks the terminal, but there is a better mode that you can use right here. So let's write the command docker run, and I'll start with the mode detached mode, so you don't lock the terminal. And I'll give this a name of node container, and I'll give this a port of 4001, 4000, which is the export port. Did you have anything else? I'll just say node test. Before I do that, let me make sure that there is no container with that name. So first delete that, because get that error that there's a container with that name already. And maybe I can also add the remove flag, which means whenever the container is stopped, just remove it. So right now you can see it's not blocking the terminal like the previous one. It just executes the commands and the terminal is open. You can continue typing other commands. And the app is running. We can see the logs if we click on it. And even more important is whenever we open the browser right here and go to localhost 4001/home, we see learning how to Dockerize a node app. It's more fun. That's perfect. Until I want to let's actually create another another approach of this, or follow another approach where I just have a page or pages, and we have index.html, so we'll be displaying the HTML code that is there. So have that, and then inside here we can just have an h1 learning Docker volumes, which that is okay. And instead of doing this, we can say constant file path. So we just want to get the file path, and I can import a library that is already built in JavaScript that is called path, which says okay, which is, let me reshare my screen. My lights have disappeared. Just a minute. Okay, sorry for that. These lights. So I'll just now use one monitor. So right here, we were in this part, which was require, and we say require something called path, which is already built in JavaScript. Sorry, this should be a constant. I'm used to writing a lot of TypeScript. We have this import syntax. So now, with this approach, we can just say path is equals to path dot, I need to get the path that we should use. And then I'll say path dot, is it always get path? I haven't used this in a while actually. Juma, this should be, is it pass or need some to get the path of this file? Anyway, this should be path dot
You
pass,
want to
I
get the
think.
path.
Yeah. So I'll pass the directory name, and then I'll pass in the pages and also index. Yeah, this should be in quotes, index dot html. So now, what I want to do with this is just to display that. So instead of just sending, I'll send a file and I'll pass in the file path. So the path is what we have right above them. So now, let's try to rebuild this image. Again, this process is not fun at all, rebuilding every time we need an image. So docker build dash t, or the tag, just say node tests and a period at the end, and the image will be rebuilt. Meanwhile, we can just delete the container right there, and we can say we build a container right there, and the container is up and running. And then we can say localhost 4001/home. So path must be a string. Yeah, I think there's a type of them. So let's see what is missing right here. So I'm pointing it to pages and then index.html, which is just and then we are sending a path right here. So I'd love to console log this path. So let me just log to the console the file path, and just to make things easier, just say npm, not npm, but node index.js. My screen is a bit small. And so that they don't crash with this one, I'll have to stop it, delete it, run this, try to expand that. And then this time I'll go to 4000. And let's see what we get. That, yeah, session, yeah.
Are you trying to get the file, the path of the file, right?
Yeah,
Okay,
I think I'm
so
missing the method.
no, you should have said path.join the name page and then index, then console log the directory. So console directory
Yeah,
path.join.
yeah, I was sure that I was missing the method. So with that, we can now start it again, and then perfect. Yeah, I think should be joined. So now, sorry for that. Always confuse methods sometimes. So now, we have this pointing to our index.html, which is again beautiful, just a different approach of things. And now we can go back to our previous way of running our code. inside a container. So I'll spin up the container right here. So with Docker command right there, the container is up and running, but our container runs at 4001. That is the port that we have connected to. And still there is that issue, which again makes me to have to rebuild that image and restart the container again. Need to stop this immediately. I stop it since we have added the remove flag. This should disappear also. It's taking time. Just delete it anyway. So that is also taking time. But now let's try running this and see. Finally they were removed. We get an image back, and that's perfect. And now we can go back here, refresh, and get everything up and running. So now our second problem is every time we make a tiny change, we have to go and rebuild this image. A tiny change, we have to rebuild. A tiny change, we have to rebuild, which is kind of annoying, good, not bad. We don't have all that time. We can use a volume that says, in case anything changes inside this folder, again, in case anything changes inside this folder, rebuild the image. So in case we change index.html or maybe something inside index.js, we'll see though for index.js. But in case we change anything, instead of me having to always rebuild this image again, automatically rebuild it. So let's see how that is possible. That is possible with something called bind map. So bind map, again, it's a volume, cannot be added in a Docker file. And on one side, you'll just say to app. So it will be like, remember in our Docker file, let me just switch this screen. It's a bit smaller for me. Just a minute. Nice. Right. So back to this bigger screen. I mean, it will be a bit comfortable for me. So we were talking about in case something changes in this folder that we are in right here, in case I change index.html or any other folder. We'll see about other folders though. Instead of me having to run this command of docker build the image again, it can automatically rebuild itself, which is a great achievement for us. So I've selected the app folder and put it on the right side of the column, the full column, which is this folder right here. And remember, that is the folder that is containing all our code. And I want to bind it to another folder on the outside. So I want to bind this to something else. And I'll come here, just click on any file here, say copy path, and paste it there. And even a better approach is to make sure everything that you have, it's in quotes. That way. And I'm binding to the all folder, so I'll remove the last part of index.js. You can still bind to a file, but this will now be this folder to the folder inside Docker container. So now what this is going to help us with, and I'll change these slashes. They deal with the forward ones. I don't know which forward is or back is, but this slashes facing the other way. That way. So now I'm binding this folder that we are currently in, into the Docker folder. So that means in case something changes in my local folder, also change inside my Docker folder. And with that, if I now click this enter, and we get that error because there is a container with that name. You can just avoid it by just giving another name. Anyway, just want to be persistent with that one name. So I remove that, rerun this again, and perfect. We now have our container running. Still shows, let's see if it has already started. Yeah, should be started, and shows that. Now I want to change something here and a paragraph and say we check with early or something like that. So if I do that, come here, refresh, I can see that, and I never had to rebuild my image or my container or anything, but now it's able to pick up the changes because I've changed a folder that I've given the direction, the directory of, and I've also bind it to another folder inside the container. So this is outside the container, this is inside the container. And with that, we are able to achieve volumes again. And this is the kind of volume that we called bind mounts, sorry. Just write the name here, bind mounts, that way. And you come here, just refresh it, you already have the file up and running. So you can think of your React app, your Angular app, your Node app. You can always bind to that SRC folder, to the app SRC folder. So that means in case I'm in development, I don't want to keep rebuilding my images, I can always bind these two files together so that if I change something in my local SRC folder, it will also change something in my Docker SRC folder. And that makes your development a bit easier. Now, this approach, however, has some problems that we'll see later. First is about something that is that depends on Node. I want to copy this. Just create another dummy URL. Just call it /dummy. And this one won't actually be using a file. Just say response.status of 200. Just means a success state. And then I'll send back an H1 just that says just hello right there back. So copy, make that better. So that way. So now, according to our logic, I should just come here and say dummy, and this works. But there's a difference between this runtime. Okay, there is something that is now specific to Node that it won't pick those changes immediately. The thing is, the image is already rebuilt, and I can show you that the image has already rebuilt by not rebuilding the image, but restarting this folder or this container. So I restart the container, and just come here back and restart it. So I never had to build the image. So that is evident that now the problem of rebuilding the image is 100% solved, but you might need to restart your container when it comes to Node, or rather be creative and use something like NodeMon that will always restart things for you. So if you add NodeMon, this will a bit save much of your time if you know how to use NodeMon. Now, the last volume that I want to talk about is called anonymous volume. And I'll do something here. I'll delete my node modules. And let's first understand what is happening before I deleted. We started by copying or creating a folder. We copied those, we installed. So that means there's a node modules already inside the container. We copy the code, we expose it, and we start it. So that is perfect. Again, keep in mind, there's a node modules inside the container. And this was done whenever we are building the image. Now we come here and say, I want to run, but I want to do something called bind mounts. And bind mounts kinda override whatever you add. And they override based on your local folder into your container folder. So you say into app from this part. Now, as we override, now on our local folder, we don't have node modules. And yeah, we can say in our Docker folder, there was node modules before because we did some installation. But now the second step where we have overridden things, then we have overridden everything on this part without node modules. So what does that mean? That now, if we come back to image, it's still running, and I refresh this, or rather I go to we still get that, but at some point, let me just first remove this image, delete it, and come back here, rerun it, runs perfectly, and we add our container here. And now look at this. The container starts and disappears. So seems like some error is happening. The container starts and disappears. So just to tell you that the issue that is happening is that node modules issue. That now our app cannot start without node modules. What does that mean? There is no Express. Express is needed to run the routes. It's needed to add the ports. It's needed to do everything about our starter file. So now it's not there. So the container just crashes. So sometimes we can say, yes, do everything about overriding, but don't override some specific things. And that is where we use anonymous volumes. So we say, override everything, but inside app, don't touch something called inside app, don't touch a folder called node modules, which we show it was created by this command here. So we just say don't touch it. You can touch the rest of the folders, but this one, don't replace it. In short, whatever is in my local, don't replace everything, but don't replace this folder called node modules. So now let's restart this up and see if our container will be there. So we have added another volume after this volume that we had right here. and the volume says don't replace the node modules folder. And with these, let's see what happens. So we have that, and let me also run this in remove the detached mode so that you can see in case there is an error. And I'll go with the attached mode. And we see that could not find module express. Exactly, that explains that there is no node modules in our folder, in our container, sorry. And the way we solve this is using bind anonymous volumes, sorry. And we'll say /app. Let me just retype that in case I missed something. /node underscore modules. We're still there. So I'm just going to rerun the image one last time and rerun everything back up to see if we should now hold everything together. Build, we'll say node test and the period part. So the image is up and it's been built. And let's restart that. But now still also rebuilding, not respecting that. So I want to change something here. I'll copy just the package JSON inside app, build that, run everything up. And then now I want to start this. Sometimes try interchanging these paths, but I don't think it's necessary right here. So let me just try it. Okay, node deleted some of the things that we wrote, but that will be up. Just say this will be another volume. Say up, I want this volume to be kept. Up, node, modules. Still replacing that folder because it's not existing in our local. Let me just do an npm install, which should make this error go. And then we can check why it's still being replaced or what is happening. So right now, if we run the container, everything should be up and running, as you can see. So don't know if I can see the structure of this container. No, I may not be able to see that, but everything is up and running and we have everything that we need. But our anonymous volume is not running. I need to know why it's not running though. See the slashes are okay. The volume is okay. And this part is also okay. So we are saying don't replace anything inside app called node modules, even if it's not on the outside. So let me check in case to see. Mm-hmm. Right. I think I'll have to check why this part is not running. Again, if the node modules is there, it will still be running, but it should not be that way. And it should be running even if we don't have a node modules folder, by the way, because this command is going to handle everything. So I'll check on that error and then update the code. But for anonymous volume, that's how you write it. The work of it is to make sure that it doesn't replace a file inside the container that is not supposed to be replaced. So the use case is okay. Just need to check if there's a syntax that I'm skipping or not taking into consideration. Once I figure that out, I will update the code and also update you on Juma. That is the session on volumes. We check on bind volumes. We've seen the importance is we don't have to keep rebuilding the images. We named volumes, you're seeing that there's a lot of persistence in the data that we have, especially with databases, and can also be used in any other case where, for instance, you are writing to files or to folders inside your Docker container. And the last part is anonymous volumes. Whenever you don't want some things replaced, you just want them kept inside the container instead of replacing it. And this is an example that we want our node modules to be kept, despite it not working at the moment. We'll fix it and see what will happen.
Okay, no worries, no worries. Is that all on managing data and volumes for Docker?
Yeah. Docker only has 3 volumes. That is
Okay.
bind mounts, anonymous, and um, named volumes.
Okay, good. So what we can do is we will prepare the next one for networking. That will be the next session. That will be probably on Wednesday. We'll have networking then. So in the group, some people were asking that they want to actually learn C# and JavaScript also. No worries for that. We will provide what you guys actually need, because you need to actually know how to do, at least you should be knowing how to program, and most of the people who joined are beginners and they want to know how to program. So we are planning that. So tomorrow probably we'll have our first session for C#, then next we'll have for JavaScript. So that's how we'll be alternating. We'll be alternating one day Docker, another day C#, another day JavaScript. 1 hour, 1 hour, 1 hour daily, like that. And I hope like you will actually like it. So you can be having like 2 sessions every week for every topic, and then on the weekends maybe we don't have any sessions during weekends, we just do on the weekdays, and I think that's okay. So with that said, I think Jonathan, we can have a Q&A session for anyone who wants to ask some questions in the chat before we close it. Yes, go ahead.
Sure.
Anybody with a question, please, before we close? All right, it seems like everybody doesn't have a question. the best thing, what I actually urge you to do, guys, is, you know, this is a live. You have seen it live here, and then it will be posted on YouTube. So you can go back on YouTube and then review it as much as you can. Like, watch that video, rewatch it again. You can stop it if it is going too fast, and that's how you'll actually learn. And the good thing is, even programming, when I teach, I will also move faster. I will also talk faster, but once it's posted on YouTube, you'll have the control of stopping the YouTube video, and then you'll practice. You can also ask questions on the channel if you have any challenges. So thank you, Jonathan. I will see you again on Wednesday. Okay?
Sure.
Sure. Thank you. Bye.
Bye.